This is June 09 AS1 and this is question 3, and it was both, the question was the same on the old spec paper and on the new one. A rugby ball is kicked over the crossbar between the goalposts from a position 25 metres directly in front of the posts, as shown on figure 3.1. And you can see there's the goalposts and there's a rugby ball. The ball reaches a maximum height h above the ground, you can see there, at a position vertically above the crossbar. It takes 1.4 seconds to reach this maximum height. Assume air resistance is negligible. Now, I think the way that's drawn is quite off-putting, and I'm going to redraw it at the side here, just beneath this. And so if I redraw that, and there's our maximum height there, you should have a parabola, and this distance here should be 25 metres, and so should this one. And this height here is a vertical height, the maximum height it is above the crossbar. It takes 1.4 seconds to reach this maximum height. So calculate the horizontal component of the velocity at the instant the ball leaves the kicker's foot. Now we know two things there about the horizontal components. We know the distance it travels and we know the time it takes. It's 1.4 seconds. So the distance is 25 metres and the time is 1.4 seconds. And those are both horizontal factors. Of course, the time is also vertical as well. And so you can easily get the horizontal component very easily by doing velocity is distance over time. And this is the only equation that we would use for velocity for the horizontal. And that gives you 25 over 1.4, and that gives you 17.9 metres per second. That's very straightforward there. Calculate the vertical component of the velocity at the instant the ball is kicked. Now, if we draw just a wee quick vector diagram here, there's the ball being kicked, and we know the two components there. The horizontal component, if this is theta, and are you told theta? No. If this is theta, then you know that this is V cos theta and V sine theta. So you could maybe do something with this, but the first thing I think that you probably want to find there is the vertical component of the velocity at the instant the ball is kicked. So we just use our vertical things that we know, vertical factors, I'm just going to call them. So we don't know u, and that's what we're trying to find out. We do know that at the instant it goes over the crossbar, its final velocity is 0. We know that A is minus 9.81, and that's enough information. We know the time. The time is 1.4 seconds. So this here maybe isn't just as useful here. So just use V is equal to U plus AT, and we're looking for U, so V is 0, U we don't know, minus 9.81 times 1.4. And that brings U out to be 13.7, and it's metres per second. So we now have a horizontal component and a vertical component. And this is going to help us find our initial velocity. So the magnitude of the initial velocity, and here I'll draw the vector diagram, which I drew the last time. I didn't really need it the last time. The vector diagram there, we now have two values of our components. We know that the horizontal component is 17.9, and we know that the vertical component is 13.7. So the initial velocity V is the square root of, this is just Pythagoras' theorem, 13.7 squared plus 17.9 squared. And V comes out to be 22.5. And that's your answer there. Right. Find the angle above the horizontal at which the ball is kicked. So we're going to use this. This is from our last diagram there. We know that this is a V cos theta. There's theta in there. And so we know that V cos theta is equal to 17.9. We know that V is 22.5. So cos theta is 17.9 divided by 22.5. And when you take the inverse cos of this, you end up with an angle of 37.3 degrees. Last question, find the maximum height reached by the ball. So maximum height is a vertical component. So what do we know? We know that the initial velocity is 13.7, that's the initial vertical velocity. We know the final velocity is 0. We know the time is 1.4, and we need S. So if you use, we also know A equals minus 9.81. So you can use anything there. I'm going to use S equals UT plus a half AT squared. And that's equal to 13.7 by 1.4 plus a half by minus 9.81 by t squared is 1.4 squared. And that gives you an answer of 9.6 metres. So think if your answer is reasonable. Does nearly 10 metres seem reasonable? And it certainly does, that you would be kicking a ball to that height.